All right, guys, this is part 2 of our review of polynomials. In this lesson, we will focus on solving quadratic equations, specifically solving by completing the square, and solving by factoring, and solving by taking square roots. All right, number 15 is hinting to you about completing the square. That thing where we do half of the middle and then we square it. Because the point of doing half of the middle and squaring it is to guarantee that we always get the same thing twice. It's to guarantee that we always get something squared. So in this case, we're getting the same thing twice, x plus 5 times x plus 5, right? That's why it's x plus 5 squared. And if we're getting the same thing twice, then we must be completing the square. So half of the middle is 5, and if we square that, we get 25. And then if you think about it, if we factored that, that would give us 5 times 5. That would factor as 5 times 5. Okay? So it must be 25. Looking at number 16. All right, so it's the same thing. We're still talking about completing the square. But this time they've already completed the square for us. We just need to figure out what we're going to get out of it. Because notice, if you take half of 6, you get 3, right? And then if you do 3 squared, you get 9. So they've already completed the square. They've already done half the middle squared and put that number here. All right, so if you have a situation where you have half the middle squared is the third number, then this should factor as the same thing twice. Okay, so if we were to factor this, of course, this would factor as x plus 3 times x plus 3. 3 times 3 is 9. Even if you do your inners and outer. Inner, you have 3x. Outer, you have another 3x. Together, that makes 6. Okay, so this is correctly factored. But x plus 3 times x plus 3 is the same thing as x plus 3 squared. So that's number 16. All right, number 17. The area of a rectangular field is this expression. All right, this is the area. If the length is this, what is the width? Okay. Well, what do you know about the area of a rectangle? I'm hoping that you know that the area of a rectangle is equal to the length times the width. Okay. So the area is 3x squared minus 32x minus 1. Wait, there's a little typo right here, so we need to change this. That should just be negative 2x like that. Okay? So if they're telling us area is length times width, and they're telling us the area. So that means in place of area, I can write 3x squared minus 2x minus 1. That's the area. And that should equal length times width. But they gave us the length as well, 3x plus 1. So I can go ahead and fill that in. So 3x plus 1. The only thing that's missing is the width, and that's what we're supposed to find. But doesn't this look like factoring to you? I've got this trinomial, and it's equal to a binomial times something. So all we really have to do is factor this trinomial, and we'll find the missing part. And it's even easier than a normal factoring problem, because it's half done. The left half is already done for us. So that should make it extra easy. So for example, I hear Antonio saying this will clearly be x, because I've got 3x times x will make 3x squared. Forget the sign for now, but what number has to go on the end? It has to be a 1, okay? Because look right here. We have a 1 at the end of the trinomial. And so 1 times 1 is the only thing that's going to give you 1. No choice. All we have to worry about now is the sign. We don't even have to worry about inner plus outer equals middle. Because look at the sign of this number. We have to get a negative 1. Okay? So what does this sign have to be here? It has to be negative. So a positive times a negative will give you negative. So boom, the width must be x minus 1. I can write that down. Width equals x minus 1. Now, if you wanted to just check real quick and make sure, then you could do your inner, outer, middle. All right? Because what do I have inner right now?
1x.
All right? Inner, I do have 1x. What do I have outer? Negative 3x. Okay? Is that giving me the negative 2x in the middle?
Yeah.
Sure. So it does work out just fine. So that's it for number 17. Okay, looking at number 18. Let me emphasize this one last time. Every year, I have 5 kids in every class that make the same mistake. On this test, we have problems that say solve, and we have problems that say factor. Okay, those are 2 different problems. They look a lot alike. They look very similar. Okay, now, so I ask you, on number 18, do I factor and stop, or do I factor and set the pieces equal to 0?
Set the pieces equal to 0.
Oh.
Okay, the difference is, if the directions just say factor, okay, that's when you just factor and stop, like these problems up here. We just factor and stop. Also, notice there's no equal sign. It's not an equation. You can't solve these. All right? If you start setting these equal to 0, you're creating equations where there were no equations before. So these are the ones where you just factor and stop. So please, on the test tomorrow, if you see a problem that has no equal sign in it, don't set these pieces equal to 0 and give me m equals negative 3, m equals 11. That's wrong. Okay? Similarly, on problems like number 18 where it says solve and then there's an equal sign, don't just factor and stop. Please, I beg you not to do that. That will be wrong. And if you do that on your whole test, the best you can get is a 50. And that's to begin with. That's if you get everything else right. So, okay, did I emphasize that enough? Okay, so we're going to factor this and then keep going because we're solving. It's an equation. So having said that, let's go ahead. 3x squared. It can only factor, all right, whoops, that didn't happen. We started off looking at 3x squared. That can only factor as 3x and x. Okay? Then we jump over and we look at the 6. All right? 6 is either going to be 2 times 3 or 1 times 6. That's the only possible way. Let's try the 2 times 3. Now, am I going to go like this? 3 here and 2 there? Why am I going to definitely not do that? GCF. Okay? All right, so shortcut is to always avoid GCF inside the parentheses. So you won't waste your time on that nonsense. You will only try this version, 2 and 3. Now, inner plus outer must equal middle, like we always do. What do I have inner?
2x.
What do I have outer? So I've got 2x and 9x. I'm trying to get a negative 17. Is there any way I'm going to get a negative 17 out of this?
Yes.
No. The most I can get is 11 out of this. So this is not working out. So am I going to try putting the 3 here? We already said we aren't going to put the 3 here. So that means the 2 times 3 option is done. It's not working. Cross that out. That means it has to be the 1 times 6. Or otherwise it's unfactorable. So I really hope it's not the case. So I'm going to try the 1 times 6. Am I going to try 6 and 1 like this? Again, no. I won't waste my time putting the 6 here. That would create a GCF. So see how much time you save by just ignoring the ones that make a GCF? Just ignore them. All right? Yes, sir. So we will only do the 1, 6 option like that. Inner plus outer must equal middle. What do I have inner right now? 1x. Outer? 18x. Looking good. What would the signs have to be to give me negative 17? Positive 1 and a negative 18 would give me the negative 17 that I wanted. Okay, so there's my positive 1, and a negative 6 will give me the negative 18. Okay, I have to check one last thing. Will that give me the negative 6 constant? You always shake your head when I ask this question. Yes. Do you see why it's going to give me a negative 6, Christian? Positive 1 times negative 6 is negative 6. Okay, so yes. All right, so great. We factored it correctly, but I don't stop here. It's an equation. We're solving. So what do? Yeah, you set these parts, these factors equal to 0, like this. Okay, subtract 1 on both sides. That gives me 3x equals negative 1. Okay, divide by 3. That gives me x equals negative 1/3. All right, so that's one of my solutions. And over here, I simply add 6 to both sides, and that gives me x equals 6. So these are my two solutions for number 18. Any questions right there? Okay. Number 19, solve by using square roots. Remember, here's the key to solving by square roots. I want you to treat this parentheses like it was one variable, like it was a q. If I had 2q squared plus 10 is equal to 24, tell me what I would do real fast. What would I do first? I would subtract 10 from both sides, right? I'd get 2q squared is equal to 14. What would I do next? I would divide by 2 next, wouldn't I? That would give me q squared is equal to 7. What would I do last? I would take the square root of both sides, not forgetting my plus or minus. That would give me q equals plus or minus radical 7. All right, now I'm going to go back, and I'm going to do all of those steps just like that. Treat the parentheses like a single variable, like a q. Okay? Okay, so I'm going to do everything that you just told me to do. First, I'm going to subtract 10 from both sides. That will give me 2 times x minus 3 squared is equal to 14. What am I going to do next? Right, just like we did when this was a q, right? The key is I'm not going to distribute or anything like that. Okay, I'm just going to divide by 2, just like I would if it was a q. All right, and that's going to give me x minus 3 squared is equal to 7. Now, what would I do if this was a q? I would take the square root of both sides, right? Square root, square root. Don't forget your plus or minus. So that's going to give me x minus 3 equals plus or minus radical 7. But now I have to do one extra step. I have to add 3 to both sides. So I'm going to do plus 3 and put my 3 in the front. Okay, so that's going to give me x equals 3 plus or minus radical 7. Please write this separately as 3 plus radical 7 or 3 minus radical 7.
Now, would completing the square be the same as